In the last term, we have started the discussion of interpolation, and in the interpolation, this Delaunay's triangulation was already covered, but I am repeating it again because today we are also going through tin triangulated irregular network, and in the tin, the triangles are created based on the Delaunay's triangulation. Okay, so does anybody remember about the Delaunay's triangulation? Why do we perform it? Any memory of Delaunay's triangulation? Okay. So I'm taking that all of you have forgotten about this Delaunay's triangulation. Basically, when you have a set of points, okay, why do we have a set of points? Because most of the time when you perform the surveying, like if you collect the elevation value or some pollution value, these things are measured at a certain location. Okay, so you will have certain point data set. Now, for different purposes, as you have read earlier, like for creation of Thyssen polygon or for the creation of tin, we need that these all points will be connected through triangles. Okay. If you have a set of points, there are n number of ways through which you can create a triangle. So it is a very difficult situation to create a triangle around them. That's why there is an algorithm that is known as Delaunay's triangulation. And this is very useful triangulation technique. In this technique, first of all, for all the points, a convex hull is created. What is convex hull? Convex hull is a convex polygon of the smallest size of the smallest area that will entirely cover the given features. So in this one, the edges of the triangulation form the convex hull. Then all the interior points are joined together by a straight line, given that no line will intersect the another line. Okay. Thereafter, triangles are created. There are certain conditions on the creation of triangle also. They should be equilateral triangle. If you draw a circumcircle that passes all 3 points of the triangle, then inside that circle there should be no other point. Okay, so these are the conditions for the Delaunay's triangulation. One example is given over here like this, that if there is a set of points, this is how the Delaunay's triangulation will create a triangle joining all the points, and see the external boundary of this triangle. Okay, on the external boundary you can find that there is a polygon, and that polygon is convex polygon. What is convex polygon? A polygon whose none of the internal angle is more than 180 degree. All the internal angle of that polygon must be less than 180 degree, then it is called the convex polygon. And in this example, you can see that the circumcircles are drawn around these points. Okay, you can see that circumcircles are drawn around all these triangles, and none of the circle is containing another point. So this is what the Delaunay's triangulation is. Next in tin, okay, write down the full form in your copy. Triangulated irregular network. Now, what is tin? Tin can be described in so many different ways. Like tin is one of the data structure, vector data structure. You have learnt about the vector data structure. Do you remember any data structure? We have learned two types of vector data structure. Can you name them? Am I audible?
Yes, ma'am.
Okay. So Nobody remember about the two data structures that we have learned for the vector data? Vector data models. It is spaghetti data model and topological data model. Isn't it? We have learned these two data models over there, spaghetti data model and topological data model. Apart from that, this one is a third one. So in some of the places, TIN is used as a vector data model. With the help of TIN, you can store the point data. It is the example of topological data model. Okay, what is topological data model? Okay, then
मैम
Sachin.
जिसमें मैम
Yeah. Yes,
मैम
yes.
जिसमें कनेक्टिविटी कनेक्टिविटी एडजेंसी मैम चेंज ना हो स्ट्रेच एंड बेंडिंग करने पे।
नहीं, स्ट्रेच और बेंडिंग करने पे तो ये चेंज होता ही नहीं है, कनेक्टिविटी चेंज ही नहीं होती है। आप किसी बलून पर अगर कोई दो पॉइंट के बीच में एक लाइन खींच दो और बलून को फुला दो आप, ठीक है, उसमें एयर फिल कर दो, तो बलून तो फूल जाएगा, तब भी ऐसा थोड़ी ना कि लाइन टूट जाएगी, वो स्ट्रेच आउट हो जाएगी। कुछ कुछ कंटेंट याद है, बीच का भूल गए। यही प्रॉपर्टीज टोपोलॉजिकल प्रॉपर्टीज होती हैं, दोज प्रॉपर्टी दैट डू नॉट गेट चेंज्ड आफ्टर स्ट्रेचिंग, आफ्टर बेंडिंग, those properties are called the topological properties. And mostly we say three types of property: adjacency, connectivity, and containment as a topological property. When we talk about a topological data model, in topological data model, the proximity information, the neighborhood information is stored, means which what is on the left hand side, what is on the right hand side, which points are connected to each other. This is what the information that got stored inside the topological data model. So TIN is also can be said as an example of topological data model. Okay. Apart from that one, we are after this topic of interpolation, we are just going to start about the elevation information, elevation data set. Over there, you will find that there is another type of data called DTM, digital terrain model. Over there also TIN is used. Okay, so TIN has a lot of uses. Let's see what will happen in the TIN. In case of TIN, there will be some sample points. Okay, usually in case of TIN, the samples are collected in such a way like it is an example of adaptive sampling. Earlier in interpolation, we have learned about the sampling type, which are systematic sampling, random sampling, adaptive sampling, cluster sampling. So this one is like an adaptive sampling where there is a change. Like suppose there is a flat surface. In that case, lesser point will be sampled over there because the variation will be very less. But if there is any slope, in that case, what will happen? There is a lot of variation. If you move horizontally, even small movement, horizontal movement will give you different values. So sampling will automatically increase at the slope. So in case of tin, the sampling is done mostly in the adaptive manner. We can we can change the sampling according to that one, and thereafter the points are joined together in the form of a triangle by using the Delaunay's triangulation. As you can see on the screen, there are different points over there and the points get stored. Okay. So TIN is a topological data structure that manages information about the nodes comprising each triangle and the neighbors of each triangle. So as you can see in this one, see this figure carefully and see this table. Okay. Are you able to understand what is happening, how this table is created? Try to identify by yourself how this table is created.
Yes, ma'am, understood.
So it is a very simple method. First of all the triangles are written A, B, C, D, E, F, G, H. Thereafter node list is given. So like triangle A, it is created by node 1, 2 and 3. For B, it is created by 2, 4, 3. Whatever order you want to take, you can take it because this one is undirected graph. If directed graph is given, in that case, we have to think about the sequence. But this one is an undirected graph. No arrow is there on the graph. Therefore, you can take any order in the node list. But once you have taken this one, okay, once you have taken, like you have taken 1, 2, 3 for the A. So see, the neighbors 1 and 2. For 1 and 2, there is no neighbor in the outside, therefore there is a dash. For 2 and 3, it is B. Okay, and for 3 and 1, it is D. Similarly, for the B, it is between 2 and 4, there is nothing outside. Between 4 and 3, there is C. Between 3 and 2, it is A. So neighbor should be written down according to the node list. Okay, it is not written randomly. Neighbors are not written randomly. It is according to the node list. So first two, then first and second, then second and third, and then third and first. This will be the order of neighbors that will be listed over there. So that is why we are saying it as a topological data model, that 10 is also a topological data model. And if you talk about the value inside this one, okay, if you try to see the value inside this one, what will be the value? The average of 3 points will be taken and the whole triangle will have the same value. In the previous turn, you have learnt about the Thyssen polygon. So in the Thyssen polygon, the polygon will have the same value as the sample point which is falling inside that polygon. Okay. See what is happening in case of 10. Instead of taking one single value for the whole triangulated area, for example, for triangle A, for every place the value will be the average of 1, 2 and 3. For B, it will be the average of 3, 2, 3, 4. Okay. Now, suppose if you see small triangles and somewhere larger triangle, what will be your interpretation for that one?
The points centered around the polygon, other points are close by. If the polygon is small, and if the polygon is large, then the other points are far away.
Yes. So if triangle are small, more samples have been taken at that place, and if the triangle size is large, then lesser sample or the distance between the sample point is more. Okay. So this is what you will interpret according to the size of triangle. Thereafter, Thyssen polygon, we have already covered the Thyssen polygon. And as I have told you, the Thyssen polygon is not just only useful in the interpolation, it is also very much useful in other type of analysis, like the analysis which is involve the delineation of area around any of the store in according to the distance. Okay, so nearest analysis, proximity based analysis is also done with the help of Thyssen polygons. After that, we have already covered IDW. In IDW, it is like a weighted average. The interpolation is done on the basis of weighted average, and where the weight is assigned according to the distance in the inverse proportion of the distance. Thereafter, we have seen the spatial moving average. Very simple method. In this one, there will be a window, and within that window, whichever sample points are falling, they will get averaged and the value will be assigned at the central position. The last one is kriging. Kriging is another type of interpolation method, and it is very much like the IDW, but the difference is instead of using distance as the basis of the weight assignment, in this case, the statistics are used. Okay, the statistics are used to assign the weight at any position. Okay, so whenever we perform the kriging, there is a concept of semi-variogram. Okay, as you can see on the screen that there is a plot between the distance and semi-variance. Okay, we are not going into a detail of kriging. It is very, it is a very detailed topic, kriging itself. And when we talk about the right now we are learning about the this geostatistical analysis in GIS. So when we learn in detail about the geostatistical analysis, in that case, the kriging is more like a mathematical topic instead of a theoretical topic. So I am just giving you a brief overview of a kriging. So in kriging, for any of the parameter, as you can see on the screen, based on the distance, the semivariance is computed. There is a formula of semivariance. On the basis of that one, this whole graph get plotted. Okay. In this one, there are three different things: nugget, range, and sill. Okay. Like, what is nugget? If the distance is 0, okay, if there is any sample point and the distance is 0, ideally there should be no variance in the collected value. Okay, the collected value should be same as the computed value because the distance is 0. But you can see that it is not starting from the y equal to 0. There is certain value along the y direction. That is, there is some value for the semi-variance. Why? Because of the noise in the data set, there will be certain value on the y-axis, and this is called the nugget over here. Okay. Thereafter, you can see after reaching a certain distance, the value become constant. Okay, the semi-variance doesn't change as the distance increases. So the particular place at which this graph get plateaued, this particular point is called the range. Okay, from the origin up to that point, this is called the range. So up to range, there will be certain variance. Okay, and this value, okay, this y value at which this range reaches is called the sill. So these are the statistical terms that are used in the semi-variogram, and with the help of this one, the kriging is used to perform, and by kriging we can perform the interpolation. Okay, so you can think that kriging, we can say that a little bit more advanced method of doing the interpolation. In kriging itself, there are different types. There are the spherical functions, universal kriging, and other things. So we are not going into that one. So this is simply like, main thing is that you got introduced with the terminology of kriging. It is one of the method of doing interpolation. It involves the statistical measure. Previously, they were not involving any statistical measure, but here there is a use of semi-variogram. There is a computation of semi-variance, and on the basis of that one, the interpolation is done. Okay. So this is all about the interpolation. Now we are moving to the next topic. And this next topic is digital terrain modeling. In digital terrain modeling, first of all, we will learn about what are the different data set or what are the different products that are available for the terrain modeling. Terrain modeling means basically it's elevation modeling. Okay. So there are what are the different products for the elevation, and thereafter we will learn about what are the different analysis. Okay, you have already learned about contour, slope, aspect, hill shading. We will cover all these things in detail after this topic. So these all are the different terrain analysis that can be done. Okay. So first I'm starting how we can collect the elevation data. Okay, how you can get elevation data. So if you think about how we can obtain the elevation data, there are several ways through which you can get the elevation data. First one is the contour and spot heights. Okay. In topographic maps, sometimes you will find such type of contour lines where the spotlight is mentioned. I will give you one example for this one. This one is the map of topographic map of Dehradun. Okay, I'm just zooming in. Okay. Can you see some light, very light brown color lines over here? And here you can see 24,000, 26,000, sorry, 2,400, 2,600, 2,800. These values are given for the line. So right now on the screen, you are basically seeing a topographic map of Dehradun. This one is just like the Allahabad topographic map that you all have seen. But here in this case, this one is the topographic map. But in this map, you can find the contour lines. Okay, so this is one of the source of obtaining the elevation. Like with such type of maps where the contours are written, you can get the information of elevation. In the Allahabad map, you haven't find this information. Why? Because in case of Allahabad, it is more or less flat terrain. Okay, but right now in the Dehradun example, the Dehradun is a hilly region. That's why the contour detail are given all over the topographic map. Okay, wherever I will open, I can find these contour lines. So this is one of the way through which the elevation could be obtained with the help of contours. Second one is, one of the branch of remote sensing involves the photogrammetry. This is a very interesting topic. With the help of photogrammetry, we can make several measurements on the data set. Okay. With the help of that one, with the help of this parallax displacement and other things, we can use a pair of stereographic, we can perform the stereographic interpretation of a paired image of the Earth's surface. So with the help of the images also, the elevation value could get estimated. Next one, which is nowadays is very useful. We have remote sensing techniques. Okay, other than images, we have other techniques. Like one of them is LiDAR. In the next semester, you will learn in detail about the LiDAR because it is one of your subject in the second semester. But you must have an idea what is LiDAR. Like LiDAR is the light detection and ranging, and in this one, laser lights are used, and based upon their backscattering, the elevation is computed, isn't it? With the help of LiDAR, you will get the this elevation data. Just like the LiDAR, there is another option of SAR, synthetic aperture radar. So it is basically radar in which microwaves are used. In LiDAR, the laser lights are used. In radar, microwave is used. So with the help of SAR data, SAR, you can think about it like a radar also. So in case of SAR, again, you can obtain the DEM data. Then there is one very popular mission called SRTM. Write down this term, SRTM. Shuttle Radar Topography Mission. Write it down. Because in most of the time when we perform any analysis and we do not have any budget of procuring any other data, or we do not have any data, we go for the SRTM data because it is freely available. Okay. This, all of you, this one is a task for you to go to this SRTM website and see the detail of the elevation which is available over there. Okay, elevation, the DEM data which is available over there. Learn about it. SRTM is very important thing. You need to learn about the SRTM data because it is one of the way through which you can get the elevation of any place. So these are the different remote sensing measure with the help of which the direct elevation measure can be done. If you see the SRTM, the resolution is not very good. But if you take LiDAR, if you take SAR, the resolution will be very good. It will be a very fine resolution data set. It will vary in few meters. Okay. The last one is GPS. Okay. This one is another useful technique. If you have a GPS or advanced GPS, if you can take DGPS and other things, you can have X, Y and corresponding elevation value. So these are the different ways through which the elevation value could get collected. Okay. So the table is given over here by maps, aerial photographs, satellite images, radar, or LIDAR, GPS, ground surveying. These are the different manners through which the elevation data could get collected. Okay. Once the data set is get collected, we need to make a continuous surface of that one. Okay, like if you have taken that elevation information from GPS or any other device, you may have taken from a few places only. So therefore, what you will do, it is interpolation that will be done. Okay, that's why we have earlier read about the topic of interpolation. Because with the help of interpolation only you can make a continuous surface. So with the help of that surface, the elevation of every place will get computed. Now coming to the elevation product, what are the possible options? First one is the DEM. Okay, what is DEM? DEM is digital elevation model. Just wait. Right now on the screen, you can find this data. Okay, this is how the DEM data appears. This is basically a raster data. This one is a pixelated data. I am zooming in, you can see. Okay, I hope it is visible to everyone that this one is not like any other, not any new data. It is like any other regular raster data in which, okay, okay, in which corresponding to every value there will be certain value which is attached to that place. As you can see over here, if I'm clicking on any place, you can see the pixel value is coming over here. If I go to the lighter tone, see what is the value? 3086. If I go to some dark area, it is 754. So DEM is like any other raster data. In that raster data, instead of in this DEM data, each pixel value will give you the information of elevation. Okay. So this is what the raster data is. This DEM data, just like any other raster data, the resolution will affect the quality. Right now on the screen, you can see the 30-meter resolution, 10-meter resolution, and 3-meter resolution. If you take 30-meter resolution DEM data, automatically the small break lines, the small deviation like small drainage pattern, fine patterns will get removed automatically. Why? Because the resolution is 30 meter. Now if you compare the same data set with the 3 meter, more clear data set is coming over here. So DEM data hold all the properties that you have earlier learned about the raster data set, and whatever surface analysis that we need to do. Okay, earlier we have learned about the slope, aspect, view shed analysis. Okay, everywhere we have to perform, we have to take the DEM data of that region. If you do not have the DEM data, you cannot do any such analysis. Okay. Now the second one is for another elevation part is DTM, which is digital terrain model. In digital terrain model, it is like, it is like a vector equivalent of that one. So in this one also XY point will be sampled. In DEM data also there will be at a certain location the elevation value will be taken. But in this case there will be irregularly spaced. Like you can take the example of 10. Okay. So it will be the example of DTM. In case of DTM, there will be a flexibility that fewer points can be taken at a very flat surface, and wherever there is more relief, more complicated terrain, more samples will get collected. Whether we are talking about the DEM, digital elevation model, or DTM, which is digital terrain model, both represent the elevation of the bare earth. Bare earth means nothing is present on the ground. There is no building, no tree, nothing. Okay. So they give you the elevation of a bare earth. But if we include all the natural and man-made features which are present on the Earth's surface, in that case, it will become DSM, Digital Surface Model. Okay. So, now, there is a question. If you take the LiDAR data, will it give you the DEM data, DTM data, or DSM data?
It will give my DSM data.
Yes. So it will provide you the DSM data. Okay. So another one is tin. We have already covered about the tin earlier. So tin is another example through which the elevation value could be represented. Then there are the break lines, not much useful in our case, but yes, this is one of the variety. Mostly when we talk about the CAD data, in that case, this can be used. Talking about the file format, there are different types of data set: point cloud, DEM, DTM, DSM, breakline. Point cloud. When we get a point cloud, when will you obtain the point cloud? Okay. So in LiDAR, which type of data do you get? If you perform the laser scanning, if you perform the LiDAR scanning of any region, what will be the type of data? Point, line, polygon. What will be the spatial data type?
Point data. Point data.
Point data.
Yes, it will be a point data, and we use the term point cloud. Okay, so you may not know right now because I do not know about the LiDAR, but in the next semester, definitely you are going to know about it because it will be in your syllabus. So in LiDAR, we get a point cloud. Okay, so when we say about a point cloud, what will be the component? There are basically four components: X, Y, Z, and intensity. So I'm not going into that one, but yes, if you talk about the file format of that point cloud data, that point cloud can become in the ASCII file format. What is ASCII file format? What is ASCII file format? Yes.
Yeah, it is a standard numbering of all the numbers to represent the in computer, American standard.
American Standard Code for Information Interchange. Okay. So
Yes.
like if you this text file, notepad file, anything, they will be in the ASCII file format. So if you have a point cloud data, it can become like in a simple text file format. Okay, you can open it in a notepad. You can get it in the shapefile format. Okay, then there is a last file format. This one is very popular in LiDAR. So it is ASPRS. What is the full form of ASPRS? Quickly answer this question. As a GIS student, all of you must know the full form of ASPRS as well as ISPRS.
Ma'am, American Society of Photogrammetry and Remote Sensing.
Yes, I'm just opening that one. All of you remember this thing because it is important. You should know about it. Yes. So right now on the screen you can see that there is Imaging and Geospatial Society, ASPRS. Its full form is, as it is given on the screen, American Society for Photogrammetry and Remote Sensing. Okay. You can see their publications. You know, they have a very interesting this grid and datums. If you are interested, you can see this one, grid and datum. This one is one part of their magazine. Basically, they have a magazine called PENRS. They have changed a little bit. Yes, PENRS. This one is the name of magazine. Photogrammetry engineering and remote sensing. This is basically a paid one, but some of its articles are freely available. Okay, so all those students who are interested in such type of, means as a, if you have, as a student of GIS or any other branch, you always read some of the magazines, in our day-to-day life. Like if you are interested in politics, you will learn, or if you will try to read some newspaper or some magazines, isn't it? But as a GIS student, we also need to learn what is happening in our GIS world or what is happening in our remote sensing world. One of the very good sources is ASPRS. Okay, so you can try down for their magazine. I'm just trying it out. I'm not sure will get open or not. In the past, usually one or two articles were available. This monthly magazine, I'm not getting their link. Yes. So it is appearing to me from 1934 to 2009. The things are available over here. Just wait. Yes. So their articles is available up to 2009. It is very old. But yes, there is definitely this section, grids and datums. You can refer to this one. They are the interesting ones. Okay. So if they are available, yeah, it is available. Like it is, this one is of 2019. Like Democratic and Popular Republic of Algeria. So here you can read about them. I have this article for India also. I will share with you in the chat maybe, or I will try to find it out. Just wait. Few years back they have covered India also. Okay, I will share it with you later on. I'm not able to locate that file, but he has also covered for the India, and it was a very interesting article. Okay, so they have covered all about the surveying things which are related to India. If you want, you can read that one. Now, yes, I was telling you about the magazine. One is ASPRS and another one is ISPRS. Okay, see this one also. What is the full form of ISPRS?
International Society for Photogrammetry and Remote Sensing.
Yes. So this one is the ISPRS. So again, for the ISPRS, there are the conferences of ISPRS that you can refer, ISPRS archives, annals. The ISPRS also have journals, and some of its journal are open source. You can read any of their article. But those students who are interested in attending the conference on the ISPRS website, this one is a very reliable place to search for the conference. So in the ISPRS, you can go to this calendar section. Like 2021 is over. So you can get several. I have opened from the calendar 2022. You can see that several conferences are listed over here. So it is not possible for you to go to the abroad, but yes, there are the online events right now because of the COVID. Some of the conferences are getting in an online mode. So if you people are interested, you can, means right now it is quite early for you because you are just learning about the GIS. But in the future, I am talking about if you want to attend any of the conference, you can refer the ISPRS. They have several events. Sometimes in India also they organize an event, one or two event in India also. So this is one of the place where we people search about the conference if student want to submit any of the paper or anything like that. Okay. Now coming back to our topic, because we have drifted a lot today. Let's close it out. Just wait. Okay. Now I'm moving to the next one. So this one was about the point cloud data that we have started the discussion, that the point cloud data can come in the ASCII file format, ISRI shapefile format, or LAS file format. Later on, you will learn more about these things in the subject. Then DEM data. DEM data, since we have seen that the DEM data was in raster file format, so any of the raster file format will be relevant. There are the various options for this one, okay, like TIFF, IMG, ISRI grade, USGS. There are the different options that are available over there from which you can get the DEM data. Okay. Then after that DEM, another one is the DTM. So again, this one is a vector data. So whatever interpolation you are creating, even after that one, you can get another file. For DSM, TIN, break lines. So these are the different data products and they can come in a different file formats. Now coming to the analysis part, in the terrain analysis, we have different techniques that we are going to learn today. Contouring, vertical profiling, hill shading, hypsometric tinting. So these are the different type of mapping that we can do. I think so we should take 10 minutes break first and thereafter I will start all this topic. Okay, so 10 minutes break and after that I will start this terrain mapping. So let's start the class again. I have uploaded that grit and datum article for India on the chart. So anyone who is interested can read that one. Now coming to the terrain mapping. First one is the contouring. Okay. What is contour lines? Contour lines means lines of equal elevation. Okay. Those lines that join the point of equal elevation, they are called the contour lines. We can interpret so many different information from the contour lines. Okay. So when we want to make any contour lines, okay, there are few things that we need to input, like what will be the contour interval, after how many points will the contour will be created, then what will be the starting point of the contour, which is the base contour. So if you have a DEM data, the example is given over here. Suppose the DEM data has elevation reading ranges from 800 to 1986 meters. If base contour was set at 800, the contour interval at 100, then contouring will be created, will create the contour lines of 800, 900, 1000 and so on. Okay. So let's see one of the example of contour lines. Okay. We already have this DEM data. Okay. Now suppose if I want to create a contour line over here, those people, those students who have created this one through surveying may have created through surveying. They know how much difficult it is to be performed manually. But here by using this elevation data and just giving the value, what will be the contour interval? Suppose I want to create at the interval of 250 meter. Base I am taking at 0. Okay. So the contour has been done. And right now on the screen, you can find these contour lines. Okay. In the purple color, you can see the contour lines on the screen. Now there are the several properties of the contour lines. First thing is, contour lines are continuous in nature. You can see that one, this thing, that they are continuous. Second thing is, they do not intersect each other. Again, you can see right now on the screen, you cannot find any two contour lines that are intersecting each other. Okay, so this is what they are saying, that contour lines do not intersect each other. There is an exceptional condition, like suppose there is an overhanging situation, there is some overhanging formation at some place, then there will be two different vertical height at that place. In that case, there might be intersection, but other than, except one or two exceptions, most of the time contour lines never intersect each other. Now, another thing you can observe over here, that there are few lines which are quite closely spaced, whilst at some other places there is a lot of gap between the contour lines. What does this thing means? What can you interpret by the gapping between the contour lines?
Flat surface.
Yes.
Where gap is more, it signifies that that area between two contour is mainly plane. And if you want to go from one contour line to another contour line of the same magnitude, the larger area will be covered, because that area is more plane in nature.
Yes. Somebody else was also answering?
Yes, ma'am. Flat surface.
Okay. So if the gap between the contour line, it is correctly told by the students that if the gap between the contour line is more, as you can see at this place, okay, it means that the change in elevation is very less. So this place, if you move horizontally, there is very less change in the vertical elevation value, means it is more or less flatter area. If you see this particular place, see how closely these contour lines are placed. It means that there must be some slope at this place. Okay, So if you are standing, suppose if you are standing on a hill, in that case, there is a very frequent change in elevation. If you just take 1 or 2 steps, there will be a change in elevation. But right now, wherever you are sitting, I think so most of the students are in planar region. So if you move few steps from your current position, there will be no change in the elevation value. So that area will be represented by largely spaced contour lines, and where there is a slope, where there is a frequent change in elevation, they will be shown by closely spaced contour lines. Another thing, I am labeling it by the height. Just wait for a minute. I will use halo. Yes. So you can see it over here. What is happening? Not clearly at this place. Just wait. Yes. So in this structure, see what is happening. Yes. Some of the labels are not appearing. I am trying to. Yes, not okay. Yes, earlier some of the labels were missing. Now you can see the what is happening as you move inside. Okay, as you move inside from this place to this place. Okay, from this place to this place, see height values 2000, 2250, 2500, 2750, 3000, 3250. Then there is a circle 3500. So which real world feature, which natural feature must be present at this place? What I'm trying to show you, I'm indicating you that there is an increase in elevation as you are moving in the inward direction, and see the size of the line, it is getting reduced. As you move towards the inward position, see these continuous, size of these contour lines is continuously decreasing. Which physical feature must be present at this place?
Ma'am, value.
Maybe hill, yeah, mountain.
Okay, there is one is saying mountain or hill, another one is saying valley. Is there someone for valley?
Yes, ma'am.
Yes. Okay. Now, if you move towards the inward in case of valley, whether there will be increase in elevation or decrease in elevation?
Decrease in elevation, ma'am.
And decrease.
Okay. So first one is what? This one is the hill shape. So as you move in this direction, inward direction, what will happen? The value will increase. But in case of value, if you move in the inward direction, what will happen? The elevation will decrease. Okay. So that's why it will not be valley, it will be a mountain or any hill. So if you move in the inward direction, and if the value of elevation increases and the size of contour line decreases, then it will be elevation. For the reverse, if you move inwards and the elevation value decreases, then it will be a valley. Okay, so this is what I am trying to show you over here. Okay, so at these places you can find the lines are more or less very placed at a lot of gap. So that's why these will be a flatter region. So this is about the contour lines. Okay, so you have seen it. The characteristic of contour lines, they are continuous, they are relatively parallel. Evenly spaced lines indicate an area of uniform slope. A series of closed contours with increasing elevation indicates a hill, and a series of closed contours with decreasing elevation indicates a depression. The distance between contour lines indicate the steepness of the slope. The greater the distance between two contours, the lesser the slope. The opposite is also true. Different type of lines should be used for the contour of major elevation. For example, 100, 50, 10-foot interval. Common practice is to identify the major elevation lines or every fifth line with a bolder or a wider line. Okay. So this is all about the contour. I have already shown you it on the software. Okay, is there anybody who has drawn contour line in their practical session, maybe in the BTech or MTech, in whichever course you are coming from? आप में से किसी ने मैनुअली इस काम को अपने लेबोरेटरी सेशन में परफॉर्म किया है?
मैम मैन्युअली नहीं पर सॉफ्टवेयर से करा है मैम।
ओके, तो आप लोग के सर्वे लैब में सॉफ्टवेयर से कराया जाता है?
नहीं मैम, मेरे जो करता था मैम उस टाइम करा था मैम।
ओके, सो किसी ने लेबोरेटरी में परफॉर्म किया है, सर्वेइंग लैब में, सर्वेइंग कैंप में इसको? यूजुअली एक आध स्टूडेंट्स होते हैं जो वो परफॉर्म करते हैं, करके आते हैं। चलिए कोई नहीं, या प्रोबेबली आप लोग ने शायद लेबोरेटरी फिजिकली करी भी नहीं होगी ज्यादातर स्टूडेंट्स ने। Next one, vertical profiling. Okay, vertical profiling is like, like suppose there is some racing competition, some cycling competition, or some, today there is Indira Gandhi's Jayanti today. So death anniversary, I think so. So there is Indira Marathon that is going on today. In Allahabad, it is there. Maybe in your hometown also it is going on. So whenever there is such type of marathon, cycling competition, racing competition, something like that, they have to tell about the terrain or what is the difficulty level of that terrain. Many times people go on the hiking, okay, mountain hiking. So they used to say that this terrain is very easy, this terrain is very hard, something like that. Vertical profiling is very useful for that purpose. Okay, what happened in the vertical profiling, as you can see on the screen, in vertical profiling, on the x-axis the distance is given. Okay, on the x-axis distance is given, on the y-axis elevation is given. So as you move in the horizontal direction, what is the change in the vertical direction? This one is given by the vertical profiling. This one is very useful if we have to judge about any terrain or we have to evaluate any terrain. So how much difficult it is to walk on that one or run on that one or cycle on that one. The manual method usually involves in following steps. Draw a profile line on a contour map. Mark each intersection between a contour and the profile line and record its elevation. Raise each intersection point to a height proportion to its elevation. Plot the vertical profile by connecting the elevated point. Okay, तो ये बहुत ही सिंपल, आपने ऑलरेडी कॉन्टूर देख लिया है ना? ये तो काफी दूर दूर कॉन्टूर बने हैं, दूसरा कॉन्टूर बनाते हैं। सपोज 100 इंटरवल पर हम बनाते हैं इनपुट एलिवेशन interval, suppose maybe or less than 50. Okay. So this one is the contour line of this region, and if I want to make a ये contour line हो गई। आप यहाँ देख सकते हो किस तरीके से जो स्पेसिंग की बात करी जा रही थी वो क्या थी। यहाँ पर अब वर्टिकल प्रोफाइल बनाना है तो क्या किया जाएगा, सपोज ये कोई रोड है और यहाँ से हम वॉक करना स्टार्ट करते हैं। ठीक है, यहाँ से वॉक होना स्टार्ट हो रहा है तो ये अलग अलग पॉइंट पर ये जो कॉन्टूर लाइन को इंटरसेक्शन हो रहा है इस रोड का। ठीक है, ये रोड जैसे जैसे जिस जिस कॉन्टूर लाइन पर इंटरसेक्ट कर रही है वहां पर उसका एलिवेशन मेजर कर लिया जाता है। ठीक है, तो यहाँ से हमें पता लगता जाएगा जैसे जैसे आप हॉरिजॉन्टली मूव कर रहे हैं एलिवेशन में वेरिएशन कितना आ रहा है, और इसी को प्लॉट कर दिया जाता है। इसी को वर्टिकल प्रोफाइलिंग कहा जाता है या एलिवेशन प्रोफाइलिंग कहा जाता है। ठीक है, हिल शेडिंग बहुत ही यूजफुल एप्लीकेशन। ठीक है, हिल शेडिंग मीन्स it is first thing is hill shading, which is also known as shaded relief। इसको लिख लीजिए अपने कॉपी में। कई बार स्टूडेंट बोलते हैं हमने तो शेडेड रिलीफ कभी पढ़ा ही नहीं है। आपने पढ़ा है, आप हिल शेडिंग पढ़ रहे हैं, उसी को शेडेड रिलीफ कहा जाता है। इसको नोट डाउन करिए। Next topic is hill shading or shaded relief. What is the meaning of hill shading? The term itself says that it is about shading and how that shading is coming on the basis of the position of sun. Whichever area is coming in the sunlit region, which is coming in the shadowed region, what will be the intensity of sunlight? Okay, on the basis of that one, this hill shading will be done. So whenever hill shading is done, we basically require three data. First one is the elevation data. In our case, it is the DEM data. Second and third, both are related to the position of sun. How we will give the position of sun? It is given in terms of two parameters. First one is direction of the sun, which is called azimuth. Write it down. Azimuth equal to direction. Write it down. Azimuth equal to direction. Second parameter for the sun position is altitude. What is altitude? Angle made by from the horizon. So these are the two parameters for the position of the sun. Azimuth, which is the direction of the sun, as you have already learned in the aspect how the direction is given. It is given in terms of north. Okay, it is given in degrees in terms related to the north. So 0 degree is north, 90 degree is east, 180 degree is south, and so on. So this is how we are going to get the direction of the sun. And then there is an altitude. What is the altitude? Like in the morning, it is nearly, like if you see a rising sun, it is 10 degree, 12 degree, something like that. In the noon, when the sun position is just above the head, it is nearly 90 degree. So it will vary from 0 to 90 degree according to the time of the day. Then slope and aspect, it doesn't matter because we are taking the elevation data. From the elevation data, all these values will get computed. Okay, so hill shading will come something like this. Okay, so what is the bright side in this figure? Where the sunlight is falling. The different shades are given according to the sunlight which is received by that place given the sun position. Okay. hill shading is a very useful analysis. First, I'm showing you how the hill shading appears. Since we already have this data, elevation data. Just wait. Okay, so this one is the elevation data right now on the screen. With the help of this one, we can create a hill shade analysis. Now, there is not just one application of hill shading to learn about the amount of light which is received at that place. It is used a lot for creating our maps. How, I will show you. But first, see the hill shading. Okay. In the practical session also, when we have this hill shading, I have told you that I will cover it in the theory session. So in the elevation, in the input raster, I am giving the elevation azimuth. Okay, what is azimuth? It is the direction. As you can see in the detail which is given over here, azimuth angle of the light source, the azimuth is expressed in positive degrees from 0 to 360 measured clockwise from north. The default is 315. What will be the this direction? 350 north, south, east, west, northeast, southeast, southwest, northwest. What will be the direction for 315 degree?
Northwest.
North?
Northwest.
Southwest.
Northwest.
इतने अलग अलग हैं कैसे आ रहे हैं? इससे
Northwest,
सोचिए और
ma'am.
बताइए. नॉर्थ वेस्ट. सबका नॉर्थ वेस्ट आ रहा है? किसी का नॉर्थ ईस्ट आ रहा है या साउथ वेस्ट आ रहा है?
मैम साउथ वेस्ट तो होगा.
साउथ वेस्ट होगा. साउथ वेस्ट ये डायरेक्शन होगी जिस पर अभी हमने ड्रॉ किया है. साउथ वेस्ट ये होगा ना. इसका कितना एंगल बनेगा? 90, 90, 180, 180 प्लस 45. 225. For southwest, it will be 225 degree. Okay. If somebody is saying this one is the angle, direction.
Ma'am, screen is not visible.
Is it visible? It is visible to anyone?
No, ma'am.
Screen is not
No,
visible
ma'am.
to anyone.
No, ma'am.
Yes, ma'am.
Yes,
No,
ma'am.
ma'am.
Not visible.
No, ma'am.